welcome to the Data-Driven Manufacturing Podcast, where we explore how data is transforming the manufacturing world. My name is Rowan Robinson, and I'm an engineer at Track My Machines. I'll be talking in every episode to engineers, business owners, and professors who are leading the way in data-driven manufacturing. Let's get started. So, Conor, we're here at NMIS. First of all, congratulations on the building, it's fantastic. Some really cool machines down on the shop floor as well. What is this place and how long has it been here?
So, this building that we're in has only been here for a little bit over a year. But NMIS as a group started out as the AFRC, the Advanced Forming Research Centre, which is just over on the other side of Glasgow Airport. But that's been there for, I think, going on 14 years now, 13, 14 years. And that is one of the high-value manufacturing catapult centres. So across the UK, there are the various different high-value manufacturing catapult centres that either look at different technologies or different regions. So it was identified that Scotland could do with a more national representative one. So the AFRC eventually grew out into the National Manufacturing Institute for Scotland. And at this National Manufacturing Institute, we have a range of different centres. So we still have the AFRC that is part of the group. We also have the Lightweight Manufacturing Centre, which looks at composite materials and lightweighting of equipment. We have the DPMC, Digital Process Manufacturing Centre, I think is the term. So that's more sort of digitalization of processes, kind of more continuous process flow type applications. And we have the Manufacturing Skills Academy, which looks at training resources and upskilling. And finally, we have the part I fall under, which is the Digital Factory. So in the Digital Factory, we have the machining and additive team, which is the team that I lead on the machining side of that team. We also have additive manufacturing capability within our team. We have metrology on site here. We have a digital team. So there's quite a lot of capability within the building. We have a design group as well. So,
yeah, it's grown up a hell of a lot in 15 years, hasn't it?
It has done, yeah. And the machining capability, some of the machines have been here for quite a long time because originally we were supporting the AFRC in the production of tooling and materials so that we could use that for the forming research, but it has grown out of that and become a much bigger thing overall. Yeah,
absolutely. I think I remember we talked to each other when I was with MTD, coming interviewing you, working on the DMG Mori over at the other AFRC.
Yeah.
You had some really exciting projects, but you're in a much smaller space. But now there's a lot more space to expand now as well.
Yeah, exactly. And that centre is still there. So. Today we were looking at jobs on the DMU 125, the same machine tool that we were at.
Exactly the same machine, yeah, so they're still moving over.
Yeah, and we still have the old equipment, and I have had people ask us, why don't you have the latest and newest equipment? And we have got some of the latest and newest equipment. But really a lot of what we're doing in manufacturing research, machine tools haven't changed all that much in a very long time. We can do what we need to with the equipment that we have. For the most part, we do look at some shiny new kit occasionally, but we try to do what is out there, or we try to work with what is out there already, and that's probably more relevant to industry as well, because not everybody's going to have the latest and greatest, newest, shiny thing.
Yeah, so, is that the thing you're trying to focus on more, is you want to be more relevant to the SMEs that you're working with day to day?
We want to be relevant to industry in general, and we want to make sure that we can capture the requirements that the industry has, and that varies massively depending on the type of project. We do a lot of varied work here. So we still work very closely with the AFRC. We have projects on at the moment where we are looking at formed components. Certain customers in industry are trying to replace traditional machine from billet approaches with a more near net shape approach, which has a lot of benefits in terms of the material savings, the cost savings potentially, but it presents a lot of challenges in, can that part actually be machined? So when you form something, is there still stress in that component? Is it going to relax and behave differently as you start removing material? How is that going to change over time? So yeah, we work across centres, and we will machine materials as well for the Lightweight Manufacturing Centre. We've got a machine tool specifically for composites that has the appropriate extraction and health and safety requirements that you need to work with those materials. So we work with the Lightweight Manufacturing Centre to produce molds for their space launch demonstrator and various other exciting bits of kit that they're working on.
Must take a lot of knowledge in different disciplines. I mean, composite machining is a complete, in my mind, I guess, a world away from machining a huge forging in titanium.
Yeah,
for example.
Yeah, there's a lot of different challenges within it. But we've got a reasonable skill set within our team. So my colleague Karima does a lot on the composite machining side of it. My background is more around the digital and connectivity side and sort of the CAD and CAM and the planning for machining. And then we have just the general metallics capability as well that links back to our history with AFRC.
Yeah, and I guess it's quite easy to get excited about the digital side of manufacturing now as we're growing into machine connectivity. Obviously, Track Machines, we do machine connections as well.
Yeah.
But you can't forget that at the end of the day, you need to make a physical part. Like, the machining is so important. It's the most important thing you can do.
Yeah.
And the digital side is more about the planning. It's more about is your cycle time the best it could be? Could you optimize your cycle, your tool paths? But at the end of the day, you need a good engineer and a good machine making a good component.
Yeah, exactly.
Yeah, so you guys need to help with the hardware side and doing those. I'd say hardware is hard. The tough projects are the ones where you actually have to make a good component, good tolerance component.
Yeah.
The hard projects are the software side as well, but I think they offer different challenges.
Yeah, they do, and we do things with. So with some of those forming projects, we can look at things like the distortion in the component as you are machining it. There's all manner of different digital things that we can collect to support those activities.
Yeah, I guess eventually maybe these two disciplines will converge at some point where if you're, maybe, I'm talking very theoretically, remember 50 years from now, if you're a good software engineer, you're automatically a good hardware engineer maybe. If you could, because you can understand the deformation of your component, exactly how your end mill runs, then you don't need someone with 30 years of, let's say, black box hands-on experience to know how that component's going to run, how that forging's going to run, or that casting. Maybe eventually, if you can read the software, you can run the machine.
Maybe eventually, but there's a lot of information that you need to feed into that sort of thing.
There is. Production engineers have a huge, and operators on the shop floor even also have a huge amount of knowledge that we just simply do not capture in software, on a website, with an app. And even in the machine tool control, we don't capture. There's knowledge there that is still in people's heads, and it's probably going to continue to be for a long time.
Yeah.
Yeah,
and that's a challenge.
Yeah, it is, but it's good thing people's jobs, definitely. Cool, so that's an interesting kind of overall to what NMIS does, all your different departments, all the different really cool things you do. What have you been doing day to day recently? Have you had any interesting projects? We're here for an event, which we will talk about in more detail probably a little bit, but give us an overall overview of the projects you're working on right now, as well as the project for today.
Yeah, so the main project I have been working on for the last little while is this Smart Manufacturing Data Hub Subtractive Lighthouse. So the Smart Manufacturing Data Hub is a larger program. So it's interesting how the funding landscape can work in the UK for research. So there's a large project that is it's entirely focused around getting companies started on their digital journey. There's a recognition that to advance UK manufacturing, you kind of need to start doing more with digital and start optimizing and improving processes. In order to do that, what we're looking at is just getting people onto that journey. So the overall SMDH project is looking at all manufacturing industries. It's not just machining. It could be food and drink industry. It could be agriculture. It could be anything in UK manufacturing. Whereas obviously, me being in a machining team, we've gone into that project and we are setting up what we're calling a subtractive lighthouse, looking at subtractive technologies. And what we found after trying for several years to get connected to various different machine tools and extract data, there's a lot of challenges that are very specific to machining when it comes to connectivity and data. I think one of the things I've observed is you talk to a lot of companies that will maybe work with robots or they'll work with PLCs, and those things are designed to be connected to other things. They will talk to each other. It's kind of a known thing that, you get a robot and you plug it into a SCADA or you plug it into whatever, and you'll probably have...
They already have a standard for connectivity.
Yeah, you'll have OPC UA or you'll have other languages, and people are used to working with it. What you'll sometimes find
some people, like automation engineers will be, but manufacturers that have robots probably have no idea how they communicate, maybe.
But a lot of the software that is out there to monitor manufacturing technology assumes you have some of those protocols available. And when you talk to some companies that might be really experienced with automation for that type of kit, and then you tell them, I have a machine tool with the Siemens control, they'll say, oh yeah, we'll use the S7 plugin and we'll use the S7 programming language to talk to the PLC. Well, it's not an S7 PLC, it's a numeric 840D control.
Yeah, it's a human machine interface with CAD-CAM built in a shop mill. It's a much more complicated beast. Much
more complicated, doesn't have the same APIs and protocols. And what you tend to find as well, your machine tools, some companies will have their machine tools plugged into a DNC so they can transfer programs. A lot of the time a machine tool is a big metal box that sits on its own, and it does its job, and it doesn't talk to other things apart from getting programs in and out. Maybe you'll do a bit of probing, maybe you'll be able to extract some probing data from it. The vast majority of companies will just stop at that DNC level, because going anywhere beyond that can be quite difficult.
Yeah, and DNC is something some companies need. If they've got 25 machines
exactly
doing batch work every day, you need to send the programs. You can't have someone running around with a USB stick, and trying to do version control like that is a nightmare as well.
Yeah.
So
but
you need the DNC.
You might fall back on the legacy approach of, for your DNC, you might use the RS-232 connection. So that's the old school standard that's been around for decades, where you plug the cable in, stream a program over RS-232. It's quite a slow process, but it works, simple serial comms. But if you want to try and do monitoring, you're not going to get that. There are ways that you can do it over serial, but not easily.
HAS machines do machine data connection with RS-232.
And there are some clever approaches using things like deprint statements to spit out information from a program.
You mentioned a company called Simco.
So
inject a statement that just spits out through the RS-232 some data to tell you what part you've made.
So Simco are an example of a company that they have a DNC software, and because they are managing your programs over DNC, they can inject those lines of code to then print back out your RS-232 comments.
It's like a hack, though.
It is.
It's a workaround.
It is a hack and a workaround, but when you're working with legacy equipment, you haven't got a lot of options.
That's the hardest thing.
One of the problems can come from, if that's the way that you approach DNC, you might have a brand new machine with a FANUC control, and you say, right, let's put the DNC on it. Where's the RS-232? It's got an Ethernet port. It will have one, and I have seen machines that have been connected up with RS-232 when the FANUC embedded Ethernet port is just completely ignored.
But you're kind of using 15-year-old. You're using a workaround for 15-year-old tech on brand new tech.
Yeah, that's the thing. And the software is perfectly capable. Usually, most of these softwares are perfectly capable of talking to these devices. Some of it is just, this is how we do connections, so this is what we'll do. But other aspects is just, I don't know what is actually available.
So there's like a standardization based on the lowest common denominator.
There can be within a company, and even just in terms of when you talk to some of the machine installers, I have seen machine tools before as well where they have a full integrated internal network. So you have maybe a FANUC control that will have an Ethernet connection to the HMI, an Ethernet connection to the tool changer, an Ethernet connection to the auxiliary computer in it to do all the simulation and everything in it. And you think, I must be able to plug into that. And then you go and you configure the FOCAS page to try. So FOCAS is an API that you can use to talk to a FANUC control. You configure that page and you configure the IP, and you're like, why can't I talk to it? And then you open the cabinet and you find out the FOCAS port isn't plugged in because they're doing all the stuff on the internal network, and they haven't considered that as a breakout. And for some companies, it's just, I think it's improving now, but you might, going back a few years, some companies just wonder why you would ever want to use that port. It's like the machine works, don't touch it.
Yeah, exactly.
I think that's also another challenge that we encounter quite a lot, is there's a lot of very specific knowledge that you need for that. So when you start talking about a network inside a machine tool, most of your maintenance engineers are going to understand, they probably understand some of the electronics, connecting the Profinet stuff up, connecting up motor drives. They can follow the schematics for that. When you start bridging out into network configuration, most people don't know network configuration.
Networking is a 3-year degree in and of itself. I've got a friend who did a Cisco networking degree, and that is, it's huge, and it can be very complicated. It can be very simple if you just have 3 machines connected up, but it's complicated.
But that example of the machine that had the internal network talking to the tool changer of SimSimilar, where we have integrated robots, if you want to plug that into your network and give it your own IP address, you better make sure that you're changing the right part of it. Because if you change an IP address, you might make it so that the control can no longer talk to the tool changer. And then your machine is down, and you have to get someone from the company.
I had this exact thing happen at Hartford. They have 2 different controls, FANUC control and the Hartford control. They talk over this internal network. I was working for a company, we were trying to network this Hartford up, and we set the IP address, because it wasn't DHCP, we had to set it to what was given to us by the IT guy on a piece of paper. We set the IP address, we set the wrong side, and we basically disconnected the Hartford control from the FANUC, and it wouldn't boot up. And we turned it back on, and we thought, oh my God, we've either fried a board, we've installed the kit wrong that we were installing the hardware, we've set something wrong, and if that machine's down, that's costing that company money. So it can be, if you don't know what you're doing, it can be a very simple thing you do wrong, but it can have very dire consequences if you can't undo that very simple thing.
And that can be extremely intimidating when you're talking about a very high value asset. Usually machine tools, they're not cheap, so people can be quite scared to touch them. And you might also have the additional pressure. You said, I need on this machine for an hour so I can do something, and then an hour later you're fixing problems, and the production leader is standing over your shoulder saying, "Can I have my machine back?"
Yeah.
But even then, it comes to doing those retrofit activities. So as an example, if you have a Siemens control, you might want to enable OPC UA, which is a communication protocol that allows you to read parameters out of the machine to a controller. But in order to do that, you'll need to go back to the OEM and ask them, can you enable it? And have they got a license available? It is a licensed option that you can buy for the machine. Maybe it's on your machine already. You need to know where to find it to get that option out. But sometimes you'll talk to the OEM and they either won't know, they might have to wait and go back. So global machining industry being what it is, there's companies all over the world. That machine that you're using here might have been made in Germany, it might have been made in Japan. You might ask your UK retailer and they might say, oh, I have to go back and ask Germany, or I have to go back and ask Japan. And then you get that communication loop where you're waiting days potentially while people go through time zone changes to wait for an email response.
Yeah, and eventually messages to go around the world and back again.
Then eventually you get a message back saying it's not an option for that machine. But it's there. It's on the control.
Yeah.
Why can't I just tick the box?
That must be so frustrating.
Yeah, and I think a lot of it does come down to just, it's so specialist knowledge. People are always really interested in the machining technology and the machine itself, and the connectivity is always seen as a secondary. It's like, that's not my core business. My core business is making a machine that makes things accurately. But that doesn't help you if you want to be able to monitor continually and see what is going on your machine tool.
Yeah, absolutely. So that's what I think at TMM, at Track My Machines, I've tried to overcome that. It's just, okay, this is a mess of standards. They're really good. Talking to Focus 2 works really well. Talking to your Siemens through OPC UA, even a Mazak through MT Connect, really, really good.
Yeah.
If you've got one of each, it's a nightmare. It's an absolute nightmare.
And that's only really good if you have a network that your machine tool is plugged into.
Yeah, if you've got trunking and Ethernet cables, great. If you've not, then that's an investment.
Exactly, which is where some of these devices like Track My Machines device on the Wi-Fi network, as plug and play as you can possibly get, really.
Yeah, so that's one thing we focus on, is trying to make it 5 minutes install. The hardware is free of charge. You get the hardware sent to you. You guys, was it Nikki here at NMIS that installed the 2 pieces of hardware?
Yeah, I actually installed it myself on the DMU125.
Yeah.
It was, the most difficult bit was just finding which of the cables to stick the current clamp around.
Exactly,
Quickly look up the electrical manual, clip it on.
Yeah.
Okay. Actually, the most difficult thing, and this is something that you'll encounter in a lot of shop floor environments, was connecting it to a Wi-Fi network that has actual public access to get back out to the cloud. It's something you find commonly with some of the cloud platforms is people just don't want to have a Wi-Fi network on the shop floor because they're scared of Wi-Fi and open access, even though you're not actually connecting your machine tool to it. Or there just isn't that facility there because they've not needed it in the past. And if it's maybe on your internal network, you would need to give it credentials and make sure it all gets allocated. So that can be a bit of a barrier for people to overcome, is just making sure you have got that network in place so you can connect that up.
But you can isolate networks. We have TMM, we generally offer a TP-Link Archer C60, I think it is, 120 quid. 4G router, stick a SIM card in. We can offer it, or you go to 3, do business deals, 5 quid a month sometimes for unlimited, 9 quid.
Data out.
Stream your data out through a 3 SIM card, 20 quid a month, and you get isolated Wi-Fi, you get security, so you can have your own fully fledged hardened IT system and then a little router sending data out to TMM.
That question on security is one that comes up a lot as well. And I think people just need to consider what data are you actually sharing and what is the appropriate level for that.
You need security clearances almost for the data.
Exactly. So if you plug directly into a machine tool controller, you want that to be as secure as possible. Because if you have something like the Focus API, I can go in and I can tell that machine, this tool that you've currently set at 110 millimeter, that's 1 millimeter, and your coordinate system isn't over here anymore, it's now over here.
That's a machine crash waiting to happen.
Then your machine's going to crash. So you don't want to just expose that out to the internet. And it's right to be concerned and make sure you have a secure connection to that. You might also have sensitivity around your data. So if I were to stream all my NC data out to a cloud platform, if that streams every line of NC code and I'm working on a customer part, they've effectively got the customer's geometry in that machining program. So you might want to keep that in local databases. You might want to look at very secure cloud platforms. But if you've got an external system that's monitoring the power data and what you're tracking is your OEE, maybe some competitors might be interested to see what's happening with your OEE, but really it's not
really
it's not
actionable.
Super IP sensitive data.
No.
It's not something that it's valid. The data is, we always say that the data is extremely valuable and you should make use of your data, but it's only valuable to you, really. It's your business. You need to be able to interpret that data and understand what you were doing with that data. And if you don't have that background context, you're not going to get that much out of it.
Yep. I remember you reminded me. There was a story I can't remember much about, but I did read one story about some people, some actors, some criminals, basically monitoring the power draw of a building in of a secure government facility or a bank or something, and they could tell when they were doing some decryption because the power draw was higher in one server rack on floor 2. And I think they tried to break in when they were decrypting because they could tell using the power data. That's a very niche example. Probably doesn't apply to an 8-machine shop even making aerospace parts. Probably doesn't apply to that shop. There's not much risk. There's never zero risk, but there's probably not much risk to energy data coming out of your machine tool and going into a secure cloud system.
And it's the same with the type of data that you're looking for as well. So there's the security concerns. There's also your use cases. So if you just want to know the operational information, the Track My Machine system is great. I can see if the spindle is on or off. If you maybe want to go a level deeper and you want to understand and associate that to a specific NC program, that's where you kind of need to plug into the machine tool controller.
You can do. We're working on some features that mean with Track My Machines you can start to see the cycles that you run on the machine.
Yeah.
I'm keeping it under my hat a little bit so far because we're still developing it, but you are right. The first data point is my machine productive? Second is, what cycles do I run?
And you can continue. I think for a lot of companies, a lot of places will run the same part over and over and over. I don't need to know the NC program because I know what that machine does. Other places will run different things all the time.
Yeah.
But again, knowing the NC program that you're running is only valuable if you can look that back up and associate it back to a component. So
yeah, absolutely.
You still need to have that overall infrastructure, I guess, and that data collection platform and the data aggregation platform.
Yeah, exactly. So this is a nice way to lead us into how is this useful for manufacturers. We had some today. We had some from Zeus Engineering, who is just I can't remember the guy's name, but they do exactly that. Is low volume, high mix, big cast parts, small cast parts, big round, small round parts, different parts every day. And then there's other manufacturers we had, so metal recycling today, who do lots of metal washing, blasting, and those machines are bespoke machines, and they do the exact same thing. They don't make parts, but they do the exact same cycle every single day. And just knowing if it's running is really useful. What happened today? Who came today? And how is talking about this machine connectivity useful for those people?
So this was an opportunity for us to give an introduction to connectivity to a lot of companies. At the start of the session, I did ask how many people have got experience of it, and there were a lot of hands saying none, basically. So just starting the journey. And there were a couple of people that have poked around a little bit and gotten some data, but the majority seems to haven't started anything. And what I found is when we talk to manufacturing engineers and we talk about connectivity, they immediately jump to the dashboard, the report, the end use data.
Yeah.
You might have if you're in a production environment, you might have a production leader who's really on top of things, and they will be trying to track how many parts out did I get out this shift, how much time was my machine active for, and they might try and track that manually through processes like just asking the operator, was there any downtime? Did anything happen?
Stopwatches, or they might take notepads, Excel sheets if you're lucky.
Excel sheets, or even just checking your part count. I got 8 parts out. They should be 45 minutes each in an 8-hour shift, so almost 15 minutes of downtime per part, kind of rough number. That gives you a starting point. It's better than nothing, I guess, but it doesn't give you a perspective as to, in that 15 minutes, what happened. Was it actually 15 minutes? Is your cycle time longer than that, and really your downtime's only 5 minutes, and you're kind of...
And are you quoting quoting it half an hour, but it's taking you 45?
Yeah.
Are you quoting it 45 and it's taking you half an hour?
And if you have got downtime, why? Like, what's going on? Because you find surprisingly common that people will think my machines run all the time. It's always busy out there. I must be up at 80% OEE. I don't know what kind of figures you've seen, but
not that.
80% is not realistic really for most companies if they haven't started on it.
Manufacturers would be surprised, and I mean surprised, at what their machines run at.
Yeah.
Even companies with full FMS systems from very well-known Finnish company make amazing FMS systems. Those machines can be, I'm not going to quote an exact figure, but kind of range between 85 and 90. These people think it's kind of 99, 98. Yeah. Even with a top spec FMS system, it's not as good as you think it is.
Yeah.
So it's really important to measure those uptimes, because you will be surprised.
And if you go back to this, the basic principle of continuous improvement is you need a baseline to know where you're improving from. You can't track the effectiveness of any improvement until you can compare it back to something. So if you don't know what your downtime is, how do you know what areas to address initially? So can you make that Pareto chart that tells you, I need to work on this particular area first? It could be material handling. Maybe your machines are stopped because you're not getting deliveries of material in time. Maybe you're breaking tools and you're constantly having to stop programs to change tools. So you need to go back to your CAM programmer and say, fix this program because it's breaking tools. There's so many different reasons that downtime can occur. And if you don't know where to start on tackling that, you're not going to be able to make the improvements that you need to make.
Absolutely. I mean, there's so many different categories. Well, there's generally, for me, for TMM, there's generally kind of 3 or 4 categories of downtime. You kind of get your human downtime. It's tea breaks on the toilet. We all have to do it. We're human. Meetings, no operator available, sick leave, holiday. There's maintenance, which is something's wrong with the machine, so or it's preventative maintenance. So there's something, spindle's down, spindle's been broken, there's been a crash. Even the coolant pump's not working. On lathes, a bar feeder is sometimes the most overlooked piece of equipment. The bar feeder feeds your machine. You might spend £200,000 on a really good lathe, but if your bar feeder, you've cheaped out on your bar feeder and it stops working, that machine's sat idle. So, yeah, so again, really, really important to look at your maintenance. And then I think there's manual work. There's work setting, tool setting. There's stuff you have to do that adds value to the process. Depending on your viewpoint, changing over parts has to happen. Changing tool tips has to happen. And those are the kind of the general, and then there's inspection quality, which is, I think inspection could get taken out completely. If you're waiting for first article inspection, you do not have enough equipment on the shop floor to measure a part in process, and you don't trust your process enough. So inspection, we should be removed out of the process completely. Should not be downtime. But those 3 categories, unless you measure it, you have no idea which day either any of those categories are having a big effect on your machine utilization.
The only point on the inspection is sometimes you can parallelize your inspection, and you might have a look at a balance. You might have an operator that's running a machine tool and also running a CMM, and they might take a part, transfer it to a CMM, and you might try and balance that split for how long it takes to make sure that you're not 10 minutes machine, 12 minutes CMM, and there your machine's waiting 2 minutes because it hasn't got the space to pass it through. And
that will depend on your batch sizes as well, and how much you inspect. I mean, I shouldn't probably make big wild claims about inspection. It's a very, very important part of the process. Quality is the most important thing you can have. Yeah. But you can have quality without even measuring your parts if you trust your process and it's locked down. Yeah. Obviously, probably measure
once you get to the high CPK, and you can be sure that you're within that window.
But we're talking like automotive high volume. There's probably not much else that probably reaches that kind of level of process lockdown.
Yeah, it depends on the industry.
So measure your parts. Please measure your parts. Brilliant. So this is kind of why it's important and useful to measure your machine uptime. And then we've talked about how to do it with your different machine controls. There's other machine controls are available as well from Fanuc and Fanuc and Siemens that we talked about.
Yeah, there's Heidenhain, there's Mazatrols, there's all sorts, but the way that you talk to all of them, not necessarily all of them is different, but Fanuc, Focus API, Siemens, you've got OPC UA as an option, and they have an API as an option. The approach that you take depends on what you've got optioned on your machine, and the age of your machine. There's a lot, they're complicated systems. You've Heidenhain, you've got another Heidenhain specific API, but again, people are used to talking to that. So what you find is the Fanuc one, there's lots of stuff about out there and people know how to talk to it, and I think the Heidenhain one as well, people kind of know how to talk to it. In the Mazaks, you've got MT Connect built in. Not necessarily active and enabled. You might have to get someone from Mazak out just to switch it on and make sure everything's connected up right.
Press the magic number.
Yeah, that sort of thing. But once it's on, you should be able to get a stream of MT Connect. If you're curious about MT Connect, you can Google MT Connect. You'll find the MT Connect Foundation, and Mazak actually have got some live streaming machines, so you can see live streaming data out of that if you wanted to understand what you can and can't do with it.
Brilliant.
And then other machine tools. Some OPC UA is starting to become more common, and when you start looking into this, you might hear of something called UMATI, which is a group of machine tool manufacturers have got together and kind of said...
Germany, from the VDW, run by the German Machine Tool Association. I went and talked to someone from UMATI last week at AMB.
Oh, good.
Yeah, interesting. Yeah, so they're trying to come together to produce like a standard that works for every machine ever. Potentially.
Yeah, and
it's a big job.
When I dug into it, because I was initially trying to figure out, okay, I've got these APIs, there's MT Connect, there's OPC UA, what is UMATI, and how does that work? But it turns out UMATI is actually just a specific implementation of OPC UA. So it's built on OPC UA, it's the same technology. The big difference is, if you go back to normal OPC UA and you switch that on your DMG machine, you might expose a variable, but it's only useful to you if you happen to know that the variable for spindle speed is $_chan1 bracket u, and then whatever array variable that is. That's not really helpful. You need to look up manuals and try and figure out what things are. The benefit of a MATI is it gives you that documented structure. It's effectively an object model for a machine tool.
Yeah, so if you build something that can measure your spindle vibration on a UMATI machine, it'll work on any machine tool that applies that UMATI standard.
Yes, it will be able to read that. It's similar with MT Connect, is the same idea. So the only difference is MT Connect is over REST, and you get an XML document back. But you can look into that XML document. It doesn't matter what the machine is. I know there should be a parameter called path. Within path, there'll be control. And then within control, I'll find my program number. I'll find my tool number. You can find various different things. You also have a parameter for axes. So if it exposes the axes, not all of these, that's another thing with these standards is sometimes you will get loads of information. Sometimes you will only get very basic information. Depends what is made available. But I know if I expand that and I see that structure, I'll see an axis, I'll be able to read the values from it. I don't have to know it's $_chan1. Oh, now it's v instead of u for the variable.
You have spent a lot of time with these systems.
Too much time.
Too much time. I don't envy you, I've got to say. But thank you for that. It's two nerds nerding out about machine connectivity.
Yeah.
You can't blame us. It's our jobs. It's our jobs. Brilliant. Now let's move on to, we've talked about the benefit, how you connect your machine up, what the benefits are to measuring your machine uptime, utilization. Last little bit, we've basically covered all of our topics, but you've got a really exciting new project, which one of our guests in this podcast, Andrew Sherlock, has already done with Innovate UK, which is the Colab project. Yep. You're doing it now with the Smart Manufacturing Data Hub.
Yep.
What is it? How do people get involved and use this tech to improve their productivity?
So the entire focus of the project is to help companies get started on digital. The event, we have set up what we call a subtractive lighthouse, which is basically we have connected our machines, we have felt all this hurt, and we have figured out how to get over, not all of it, but how to get through most of it. The description of it as a subtractive lighthouse is quite helpful actually, because when we talk to companies, you get bombarded with so many different standards. You've got, as I said, Profinet, Profibus, OPC, UAM, just overwhelming, and then you go to the physical connections, you look at everything. It just becomes too much. It becomes this fog that you can't see through. So the objective of our lighthouse is to be that beacon through that fog so that you can start to plan your journey to get to digitalization. And the way we've delivered that is we've connected a whole range of different solutions to our machines here. So you can come and talk to us. We can show you what we have deployed. We can show you some of the challenges that we've had to overcome to get that deployed. But you can also reach out to us and we can do what we call the same model as with the Colab project. We can do Kickstarter, then training, and then Sidekick. So Kickstarter is we come into you as a company and we chat to you initially, understand where you sit currently in this landscape. Do you have the skill sets on site, or are you looking for external providers? Do you have a network on site, or are you looking for different types of solutions? What are you trying to achieve from your system? So the objective of the Kickstarter is for you to scope a project for yourself to do and give you that understanding to get started on that project. Because we speak to some companies and they're just like, I've got 30, 40 machines, mix of legacy, mix of new. I don't know what to do. I just know I want to do something with digital.
Please.
I want to do digital, but I don't know what. Okay, let's help you find out what you can do. And then you get other companies that will know, I've got these machines, I know they've got this protocol, I have this very specific use case where I want to change how I'm programming and I want to measure the benefit I get from that. Okay.
It must be a lot easier when they've got a specific problem.
It depends, yeah. It should be easier when we've got a specific problem because that's effectively a lot of the Kickstarter scoped out. And then what leads on from that is the training. So once we understand what you are looking for, we can try and help align you with some training that is available so that you can upskill and learn. So if it is machine tool networking, we can help you out with some networking stuff. If it's maybe database configuration or some of the more IT side of it, we can look at that. But we can also link you up with companies if you just want to know what is out there in industry. We can point you to the right people in industry to talk to. And then finally, there's a Sidekick, which is you scoped a project, you've learned what you can about it. Now it's time for you to go off and do your project. But we are available on the end of the phone. We can maybe come out and visit your site and help you out if you get stuck somewhere along the way. And that is all funded through the SNDH project. So effectively that pays for our time. So you don't have to pay anything as a company to get our help. We just engage with you under this project with a limited scope of, obviously we have to put some limitation on it. We can't just work for you forever. And importantly, the project runs up until February. So up until then, we are able to just speak to you and tell you, spend a good bit of time with you and talk to you about connectivity. And
data science team in a box.
So our data science, yeah, we can link into a data science team. So What you've spoken about with Andrew is more on the data science and analytics side. This project is more about getting the data.
Okay,
to
so
then feed
machine
into the
connectivity
data.
team in a box.
Yes.
That's what you get.
Sorry.
Is there any geographical limits?
Not specifically, no. It's all
UK.
across the UK. And
Brilliant.
there's a range of different lighthouse projects as well. So we have set ours up for machining specifically because we're a machining team. We've been looking at the subtractive processes, but there are other lighthouses looking at other industries. In fact, Bacardi we're in as one of the group today. Don't know if I'm allowed to.
Yeah, I think you're allowed to mention them. Yeah.
Just GDPR, need to be careful. But yeah, we've had other industries in that are interested.
Yeah, food and beverage have been here. We mentioned metal recycling have been here.
Yeah.
Standard machine shops, 20 miles. Airden, place called Airden.
Airdrie.
Airdrie, yeah, really close as well.
Yeah, loads of local companies, but more broad across the UK companies
Exactly.
as
So if you're interested in getting your machines connected up or exploring machine connectivity and starting your digitalization journey, NMIS can help you up until February.
Up until February. We can still help you beyond that. We just won't have the funding to, so we'd have to look at what their projects are available. We can work through directly funded models as well. So yeah, if you wanted to do a connectivity project, if you wanted to do something as well that was more in-depth than what we can go through with this project, then we could scope out effectively a directly funded project, or we can look at research opportunities to try and help join you up with other people that are interested in the same thing.
Brilliant. Thank you, Conor. So if that sounds of interest, then get in touch with NMIS, Conor Mac Fadden. I guess you can probably try and find his direct email, send him some inquiries. And that's it. Thank you so much for listening to the podcast looking at waste in manufacturing, trying to shine a light on the things that you can't see but are really important in your machine shop to try and improve your productivity, the things that are costing you money that we can try and reduce with technology. Brilliant. And that's it. Thank you very much for listening.
Okay,
See you
thanks.
again.
Thank you.